Bill. I'm Jeannie. We're two do-it-yourselfers met on a sailboat in 1988. 3 houses and 4 boats later, we're refitting our 1998 Seahorse Oceaneer 55-foot steel trawler, Blue Sky. Welcome to our journey. Last week we got the new batteries and battery chargers mounted, so now we're ready to wire.
We're making up some of the wires. I've already made up 5, well, at least got the connectors on the wires. I still got to label them and put heat shrink on them. But we'll go through the process I use to make these high gauge, high current cables. Anyway, we use a plumbing cutter, just a normal ratchet plumbing cutter. You do go through the blades pretty quickly, so it's nice if you have one that has the replaceable blade, which I don't know if Home Depot does that anymore or not. But anyway, you can get down in there and it will make slicing through
Like butter.
Oh yeah, almost like butter. You get a really good cut, clean cut with it, and it's a lot easier than a pair of bolt cutters. Then we have our box of lugs right there, and this is a 5/16 2/0 or 2/0 5/16 lug, because that's going to the battery. But I come in and I just lay the lug up there, kind of mark it with my thumb, get my razor knife out, and then just walk the blade around the wire. Don't have to push too far in, just kind of on the surface, because you don't want to score the wiring. You just want to weaken the insulation. And then once you get it all the way around, I then come in and do the one end, and then I can just peel the other part off like that. And now I can take my end fitting, slide it on, and you push those wires. You want it flush to the insulation or the cover. And then I take my crimp tool, just a basic manual one, and line it up and push it all the way down, and that gives crimping in several places. It puts a big crimp into the bottom there, and then it also crimps the sides down here, so you're really compressing the material. And there's that one, there's that side. The only thing I don't like, if you get a little close to the back there, you get this little kick up, so probably should have made it a little closer to the base there. But you know, the heat shrink will cover that. And what you can also do is you can take a pair of lineman pliers, open them up, grab that, and then squeeze, and that'll flatten that out, so you don't have to worry about it being a wear point. And then we'll do the other side. Your lugs are supposed to match the screws they're going on to, so I need 3/8 here. So we'll get that guy out, I'll mark it, start my walk, then do my end cut. In the end cut, I go ahead and push all the way down so it splits it. Because you know, if I score a wire, it's going to be one wire that's going to have a longitudinal scoring, so it won't be in the flex region. And then we take this guy, and hopefully these guys haven't expanded too much. Squeeze him on. Depending on your lugs, all of mine are in the same plane, but sometimes you may have one that needs to be rotated. And we will put this guy on here, and I'm going to do him a little further towards the front so that I don't get that pop up. And there is that guy, all done. Now we will add labels and heat shrink. It's going to be 12 volts. And there's the forward breaker. And the reason I put 12 volts on this is because part of the circuit is going to have 24 volts. So I want to be able to distinguish what's a 12 volt wire very clearly from a 24 volt.
A bigger one than that.
There it goes. Okay, trim it. I like the clear for a couple of reasons. One, I only have to buy one color, don't have to have a whole bunch of red and a whole bunch of black and a whole bunch of yellow and so on and so on.
The clear what?
Clear heat shrink material. The other reason I like it is I can put labels. Since my tube label maker won't go all the way up to 1 inch, I can put my labels underneath the clear and you can still see them, and that keeps them from ever coming off. And I can inspect the seam here, so if something starts to happen where I start seeing corrosion or whatever in the joint, well, it'll be quite obvious inside the clear because you'll see the water in there, where with a a solid one, you have no clue what's going on inside of there until it fails, or you cut it off one day and go, oh my goodness, look at all that green corrosion in there or whatever. And now we're going to heat shrink it. I'm trying to hold the wire with my needle nose pliers here, and they're not that great. I really don't want to burn my hand. The heat shrink has glue in it, so I like to see the glue start to come out, especially on these big ones, so everything is well sealed. You can see the glue coming out. First of 6 wires in this group, and we'll bring you back when we get the other 5 done. Later. Okay, there is the first set of wires, all heat shrink wrapped and ready to go down, so we'll be installing them next. This is the first set. This is for the port battery to turn it in from 2 single cells into a battery bank, which will be 2 cells in parallel, which will give us the 600 amps that we need to power the bow thruster. Actually, the bow thruster needs 500 amps, but this will give us BMS for each battery is rated at 300, so in parallel we'll end up with being able to pull 600 amps if we need it. Hopefully we won't have to pull that much out. Later. We have the breakers and the posts permanently mounted now with the proper screws. So we'll be attaching wires in a moment, but I need to clean up this wire right here because this is using an old piece of wire from the original wiring on the boat, but we saved it because this wire is so freaking expensive. And this crimp, I even saved it, even though it's an all copper one, not tinned. Normally you use tinned ones because tinned ones don't oxidize like these do. I want to make sure it's nice and clean before I put it on over there. Go ahead and disable the breaker there. Put that guy on. Get our nut going. Okay, get the cover on there now. Okay, one cover and cover. Okay, there we go.
Okay, so you got to do that how many more times?
That type of setup, 3 more, but there's a bazillion other wires going to other different things.
So we'll come back in to show after all that's done. Later, have fun.
Oh yeah, later. We're getting ready to assemble the main breaker. This is a 600 amp breaker for the system, and one of the issues I have with the design is it has these protection covers because I think it's rated for 1,000 volts. Yeah, 1,000 volts and 600 amps. So needless to say, they have little guards here to protect your fingers and whatnot from getting into where that contact is. Trouble is, you can't, you have the bolt here, which has a, oh, these are actually, I see, it's pressed on, so that won't fall off. But then you got to have some way, and maybe there's a tool that clasps this, or you can get a magnetic one. I don't know. But anyway, what I'm going to do is I'm going to go ahead and assemble these outside, but I'm going to do it upside down. The nice thing is then this drops down. I can take this and insert it up and in, and then all I have to do is kind of hold this piece like that and go through my hole, and then get that to go into. That's now hooked on.
There it is.
Just take the lineman plier here and take this guy down. So there's one wire hooked, so now that's going to go up to the post. Now we will put this wire in on the other side. Up and in. So there's the in. Just got to line it up. Okay, now that guy, I think, is on there. Oops, no he's not. Oh, here we got him this way. Doing the breaker wires up here because I think it's a little easier to do them here than with the breaker mounted. Okay, hopefully this guy will reach. So there's the entire assembly. That being going to the post, that's going to the battery switch. Got the main power line hooked up to the remote battery switch there. So then that'll come on up here. We'll end up putting a wire tie there, and one up here. And the breaker here is mounted now. And then it goes on up to the post. And now what we're going to do is I'm going to hook up these 2 breakers and then measure the wires to go from these 2 points over to here. And also the 2 ground wires need to come to this post, and then those ground wires will come down and go to that point right there. which will then make our 24-volt circuit. All of the big battery wiring will be done at that point, and we'll be able to start testing some of the equipment. 12-volt circuits we hooked up last night. Oh, we do have one more thing to do in here. Got to hook up these chargers into the 2 batteries later. Everything is wired in, including the Watt cycle shunt. Oh, did you plug that display in? So we'll have that shunt. So that's going to monitor the 12-volt side. We have the Vectron shunt monitoring the 24-volt side. I'm going to bring that power pack to life. The 12-volt one we've brought to life already. The 24 one we have not. I'm going to get the power pack to life. I'll get the second 12-volt one, which is 24 volts. I'll bring it to life. And then I'm going to enable the 2 chargers to make sure they don't have issues. And then I'll put the 2 packs together. That'll put 12 volts on that end, which will bring 24 up to there. So you ready for me to go ahead and give you 24 or 12? I guess we'll do 12 and then it's power supply. Okay, I'm enabling this pack over here, which like I said, we have done already. So did anything happen on the display?
Right now, 0 milliamps are being pulled out of the pack, and it shows 13.3.
Fire up the charger, and then we'll come back to that. There's that one, seeing something. What's that display showing?
Sure, that's interesting. Right, so the shot doesn't even work.
The rear port battery is charging with 30.2 amps, or 407 watts, which is what I'd expect to be doing. It's in parallel, so 30 amps goes to it, 30 amps will go to the other one. So if you'll hop over to the other one now, we should see somewhere close to 30 amps going to it. You can also see that on that little display maybe. Yeah, and that one's showing 391 watts. A good start. So now I am going to engage the batteries over here. Now will give us 24 volts. Well, it'll give us 12 volts down there, which of course are these ground batteries. And this is my only fear, is if these chargers are not isolated, like if they take this ground and ground it to this ground, then these breakers aren't going to be on for long. That'll be a quick test, and it won't happen until I plug that in, I think. So anyway, going to do this guy here and that guy there. Should have 24 volts up here, ready to go into the breaker. Yeah, we got 27, 25, so we should be able to do that. In theory, those guys are enabled. Great. Well, something's not happy. Did not last very long. Okay, so something blew. Something did not like power, so either the breaker blew or the BMS is kicked off. Oh, it's back to 20. Yeah, it's back. Great. So why did the BMSs kick out? Seem to be truly rated for 300 watts, unless I lost one. But they came back, but it's all that work and they don't work. Great.
Check in next week to see if we figured out the issues with the batteries. Thanks for watching.